Saxon's Calculus, Lesson 11, is polar coordinates for vectors and then polar coordinates for complex numbers. So before I start this, I'm going to review our little chart that we learned in trig class last year. So we have rectangular and we have polar, and we have our regular and complex. So in our regular rectangular coordinates, we've got I plus j, and in its polar form, it's hypotenuse with the upside down and the degree. For complex, which means I'm dealing with imaginary numbers in my answer, the rectangular format has the I sliding to the end, so it's a number plus something or other I. Oh, and technically these are all those little extra things in there. And then for polar, it is the cis format, which stood for cosine plus I sine, but that was the abbreviation. And so what I know is that I'm going to have the I attached with the second half again, just like in there. So now example 1 says convert negative 3i plus 2j to its polar form. So here it is in normal. We want hypotenuse and then the degree in here. So we're going to graph. And so negative 3, this is for my x, this one is for my y. So negative 3 on the x, 2 on the y, puts the dot here, connecting the triangle always to the center and always connecting to the x-axis, never connecting our triangle to the y-axis. So then I'm going to label this as negative 3 and this as 2. Since I know I want my hypotenuse, I'm going to Pythagorean theorem. So 2 squared is 4 plus negative 3 squared is 9. So that's 13. So the hypotenuse is square root of 13. Now I still need the degree for in here. So that's going to be, and I can use any of them, but I want to avoid this radical 13 because it's a decimal. So which word could I use, sine, cosine, or tangent, that deals with the 2 and the 3, the opposite and the adjacent? Well, that would be tangent. So tangent of the degree will be TOA, 2 over the 3. Again, I don't care about that negative sign. So on my calculator, I'm going to do 2 divided by 3. Inverse, second, or shift to get the degree from my calculator. And so that should tell us that it is 33.69. And then this is in the second quadrant. So when I fill into my actual answer, I am shy of 180 by 33.69. So 180 minus that provides us with 146.31 degrees. Now, 1 second. It said convert to polar coordinates, done. Write the 4 forms of the polar coordinates of this point. So this is the first one, but I know I need 3 more written. So if you remember from trig, you have 2 that have a positive hypotenuse and then 2 that have a negative hypotenuse. So in this next one, in quadrant 2, where this landed, what I'm looking for is the negative degree. So I'll have a positive and a negative degree and a positive and a negative degree with this set as well. So from 0 going backwards here, 0, negative 90, negative 180, plus another 33.69 takes me to negative 213.69 degrees. To get the negative hypotenuses, I take the quadrants in and I flip it to the opposite one because that negates the hypotenuse. And when I do that, then I'm getting these 2 answers, and now I need the degrees that go with them. So working, I usually do the forward one first, but it doesn't really matter. This one is so close with the negatives. It's just negative the 33.69 degrees. And then this one, the positive version, 0, 90, 180, 270. I'm just shy of the 360 by the 33.69. So do 360 minus that and get 326.31 degrees. So you see 2 positive hypotenuses, 2 negative hypotenuses. one with a positive, one with a negative degree, one with a positive, one with a negative degree. That's all 4 forms of that in polar. Now, example 2. Add -4, okay, and they're giving it to you in polar form, but their way of doing it is, honestly, it's weird. It looks like an angle symbol, and I don't love that calculus switches to this. They could have just drawn the long hypotenuse box like normal. This is not, I think, a standard way to write it, but if they're writing it in here, they're wanting to prepare you for the standardized testing just in case. So this thing that looks like an angle symbol because it has the flat bottom is now supposed to be your degree. And then that little thing is sitting right in front of -150. I guess they could be saying -4 with degree -150, but it should be in polar form, which is this. Anyway, moving on. +8, and again, they're doing it, and I dislike it, 300 degrees. I'm going to write mine inside the box. So we're going to graph these. -150 going this way. 0, -90, -180. Okay, I didn't reach -180, so I'm shy of 150 to 180. I'm shy by 30 degrees. So I know that, oh, I have 2 options here because it's 30 degrees. I'm going to go ahead and do my way, and then I'll remind you the calculator way. So opposite of 30 is a 1, -1 based on that quadrant, and adjacent is √3, negative based on that quadrant, and the memorized hypotenuse would be 2. Now, here's the little kicker. When I look here at the actual hypotenuse that they gave me, it's -4. Well, I can't have that, so I need to switch it to this quadrant so that it's no longer -4, but hold that thought. I'm asking myself 2 times what gets me to the 4? Well, that would be a 2, and if I have to multiply this by 2 to match what they gave me, all of these need to multiply by 2, so that's going to become -2, and that's going to be -2√3. So when I move things over, this is my 2√3, this is my 2, and this is now the 4. Okay, and that's matching with the hypotenuse. All right, and then, oh, so what I needed was my I and my J numbers from that. So if I want to go ahead and write that, 2√3 with my I plus 2 with my J. All right, now we need to do this one, 300 degrees. 0, 90, 180, 270, so it's definitely in this quadrant. I'm shy by 60 degrees. Okay, got to reorganize my thoughts here. That interruption was a little bit long. Oh yes, 60 degrees was in the gap. So I'm going to do the same thing. Oh, I forgot to tell you the phone rang. Yes, I forgot to tell you the calculator version of doing this. So they're suggesting that what you do, and I'll just do it over here, is that you do the sine of 60 equals, and that would be the opposite x over the given hypotenuse of 8, and then do sine of 60 times 8, and that'll give you your I number. Do the same thing, cosine of 60 times 8 will give you this number, and then of course this one would be positive, this one would be negative based on the quadrant. I'm going to do my same thing I did over here. So opposite my 60 is √3, adjacent is 1, oh, that'll be negative, and hypotenuse is 2. But they didn't give me a hypotenuse of 2, they gave me a hypotenuse of 8. So 2 times 4 is the 8, so this is going to change to 4 and 4. So then my 4i, because they're being combined together, I'm going to add these two together, and then the minus 4√3 with the j. Okay. These are not like terms well, they are, but they're not. I can't actually combine them because this one doesn't have a √3. So 2√3 plus 4 with my I, and then, oh, I have the same problem there. That'll be, I'm going to do a plus and then do a parenthesis. 2 minus 4 root 3 with the j. So this is the answer, but it is in rectangular format. I need it, because it started in polar, to be in polar format. So I need to, now I'm no, they're different. I paused the video there to do a double check whether they actually wanted that graphed and put in polar. Technically they should. However, they did say that they're going to not do that for this example, and they just put it in decimal format. So if you had done this with both, they would have already been in decimal format. Because I did my version with the root 3s, I had those in here. So what they said was that this combined together would be 7.46i, and the other would be minus 4.93 with the j. So either one of these answers is going to work. So if you did it with the decimals, this is where you should get, or if you converted this down, you should get to that same answer. Okay. Part B now is the polar coordinates for complex numbers. So that, I just flipped the page, but I should have left it. Ooh, so much flipping on your video, sorry. Here, what I'm talking about is this part of the graph where we're doing complex numbers, so our i's have shifted to the end. So a rectangular format is blank plus the I number, and this one is in cis for the polar form. Okay, now that I've reviewed that again, example 3, write the decimal approximation for 6 cis 20 degrees multiplying with half cis 10 degrees plus 7 cis negative 300 degrees. Yes, okay. I want to fix that 7. It didn't look very clear to me. All right, as a complex number and in standard form, so we don't need to worry about anything else. Now, the first thing you need to remember is that when I am multiplying with the cis format, you are multiplying the numbers in front. So 6 times a half is 3. The word cis is going to stay there, and then the degrees, rather than multiplying, add. So 20 plus 10 is 30 degrees plus our 7 cis of negative 300. So we're going to graph our 30, quadrant 1. I was debating which is the best way to do it. Again, anytime they're in there memorized, my instinct is to do the 1, the root 3, and the 2, and then the hypotenuse isn't really 2, it's 3, so 2 times what is the 3? Well, that would be 3 halves. So this one would change to 3 halves, and this one would change to 3 root 3 over 2. And then on our negative degree, 0, negative 90, negative 180, negative 270, it's in the first quadrant, shy of the 360 by 60, so root 3, 1, and 2. The hypotenuse, though, is really 7. 2 times what is the 7, so that's 7 halves, so this is 7 over 2, and this changes to 7 halves. And then we are adding those together. So I'm pretty certain that they're going to have changed these over to decimal formats, or originally they did sine of 30 times 3 gave them their their y value, their opposite, and cosine of 30 gave them their x value, their adjacent, and then the same thing over here. So when we've put those together, I'm looking for their decimal here. 6.10 I, the I is the one that shifted to the end, plus 7.56, and then the I shifts to the end because this was complex to begin, because it was in cis format. So I know I don't have to take it back to cis format because it said leave it in the regular format. And just to clarify again, where did I get these numbers? I'm doing 3 root 3 divided by 2 plus 7 halves. That should be getting you this decimal. And 3 halves plus 7 root 3 over 2 should turn into that decimal.